Hey guys, Michael23B here, and welcome back to another Redstone video. And today, what we're going to be tackling are one-wide tileable gravity block sorters. Now, if you've seen my original video explaining gravity block sorting technology, you'll know kind of how this works, but I will give a brief explanation here in just a moment. So first, what we're going to start off with is actually talking about dragon eggs and anvils and stuff like that. I must have gotten at least a few dozen comments about this, like, can't we sort anvils or dragon eggs? And the answer is no, we can't sort anvils or dragon eggs or whatever with the technology I'm talking about today, because we can't push anvils with pistons. See, it doesn't go anywhere, and dragon eggs, this breaks when I try to push it. And same should go for suspicious sand, suspicious gravel. These things break, just as you can see here. But you can push them while they're in the falling block form. So if I were to place a block in front here, we can push it like that. But this is completely useless, because in order for the sorting technology to work, it has to be able to schedule it as a physical block. And yeah, you can't sort something if it's already a falling block. So now that that's cleared up, let's talk about how the sorting is actually going to work. I did explain this in my original video, but this time what we want to do is make it one wide tileable. So in my original video, you could only sort one block at a time, whereas this time what we want to do is, for example, if I were to stack this 10 times, we want to sort a whole row of blocks all at the same time. So the goal is to be able to sort different blocks into different stacks. And each one of these slices needs to not interfere with each other. So a signal from this one needs to not interfere with the signal on the left or the right of it. Otherwise, that could break the machine. So here, let's break down the required components. So first of all, we need an activation device. In this case, I'm using string, which you can barely see, but it's right there. And if we go ahead and open up the HUD, you can see that it has certain properties. And if I were to stand in it, you can see the powered state switches to true, and that state is detectable by observers, and then we can send that to the next thing. So then what we need are two zero-tick pistons, and I'm going to go ahead and call this sand the control block, because it's the block that we want to sort for, and this red concrete powder is the block that we're actually sorting through the system. So if you don't already know, the way that the sorting technology works is that if we were to zero-tick this piston, it instantly pushes its sand out to here, and then this position that the sand is currently in, it schedules itself to fall in 2 game ticks, but then on the very next game tick, we're going to zero-tick this piston, which instantly pushes this red concrete powder out to here, and it pushes this sand back to here. So now that the red concrete powder is here, it's going to schedule itself to fall in 2 game ticks. And then on the very next game tick, what happens is that the tile tick that the sand block scheduled in this position expires. And if it's still sand, it's going to instantly turn to a falling block entity, and it's going to start falling. But if it's not the same block, then it simply does nothing. And on the very next game tick, this is when the red concrete powder's tile tick is going to expire, and then it will instantly start falling. So this means that any block that doesn't match the control block over here is going to take 1 game tick longer to turn into a falling entity than one that does match. And this single game tick difference allows us enough time to push the mismatch to a different location. So I don't currently have anything hooked up to these pistons, but we can go ahead and simulate this action by zero-ticking this piston and advancing the game 1 tick. You can see it instantly gets teleported to here. And then if we zero-tick this piston, advance the game a tick, you can see this happens. And then this block, since it's not a match for the sand, it's going to fall in 2 game ticks. So we can go 1 and 2, and you can see it turns into a falling entity. And if we time this piston right here correctly, we could push the mismatch to a different location. So let's go ahead and advance here, and I'll break that. And we can go ahead and try it with the sand now. So let's go ahead and zero-tick this piston, and we'll advance the game 1 tick. Instantly gets teleported. We can zero-tick this one, and it pushes it back. And since the previous sand already scheduled a tile tick in this position, this new sand, instead of falling in 2 game ticks, it's going to fall on the very next game tick. So you can see it instantly gets turned to a falling entity right away. So that is our 1 game tick difference. And yeah, from there, the rest is pretty self-explanatory. We have a piston here that we want to fire at a very precise time. That way it only pushes the mismatch and it allows the match to go through. And we're also using a trapdoor here because of its unique hitbox that is very high up. That allows the falling entity to get moved over to here. And once it falls onto here, we're going to fire this piston, which pulls the mismatch back, and then that falls and it could fall into your next module. And then of course we also have this piston. This would be for the output line. And this piston would be used to push all your matches out to your output line. And you can take that wherever you want to go. So hopefully you understood that. Really, the main component of this is using the zero-tick pistons. And I've already explained zero-tick pistons in the previous video. But the other component is that we need them to fire one game tick after another. And there's two main ways to do that. There's leaves and there's scaffolding. And what you may or may not know is that most components in the game operate on a 2 game tick cycle. So this observer, when it detects an update, it takes 2 game ticks to fire, and then the next one will take another 2 game ticks to fire. And same goes for repeaters and stuff like that. This is going to take 2 game ticks to fire. If we do it to the next setting, this takes 4 game ticks. This is 6 game ticks. This is 8 game ticks. And yeah, if we go ahead and update this, you can see the pistons operate like that. And that's kind of slow. You can compare it to the leaves like this, which operate much faster. And now since we're using leaves, instead of there being a 2 game tick delay between each piston firing, there's now a 1 game tick delay. So the way this works is that these leaves, if we go ahead and open the HUD here, you can see they have a specific property denoted by the distance value. So this distance value is keeping track of how far away it is from a log. So this one is 1 block away from this log. This is 2, this is 3. And for each leaf update, it takes 1 game tick. So this is going to update first, and then on the next game tick, this updates, and then this one updates. And yeah, you can see that. So now it's 2, 3, and 4. If we go ahead and place it back, now it's 1, 2, and 3. And yeah, same goes for scaffolding. This one also has a distance value. This is the distance from the supporting block. So right now, the supporting block is the iron trapdoor, as you can see here. So the distance is 0 because this trapdoor is currently supporting it. And then this is 1, this is 2. And then if we go ahead and open the trapdoor, then this trapdoor is no longer a supporting block. So all the distance values get changed so that this is now the supporting block. So again, we have a 1 game tick delay. And yeah, these are the 2 main ways to get a 1 game tick delay. So now let's dive into some of the actual designs. Now I am going to exclude some of the iterations that simply didn't work. But for example, with this one, it's important to note why it didn't work. So with this one, we're firing multiple pistons all at the same time, no matter if there's a block to sort or not. So some of the time there isn't actually a block that's being sorted, and this is causing the control blocks to fall out because there's no block to push the control block back into position. So overall, this one has some weird functionality because either the control blocks fall out or they get moved to a weird position. And yeah, this is why we need a 1 wide tileable design that doesn't interfere with the slices next to it. So it needs to be independently controlled, unlike this one. So this is one of my first designs for a tileable sorter, and it is objectively the worst, most non-compact version you could do. But if we go ahead and break down the components, you can see we have our activation method here. We have our 0-tick pistons and our 0-tick generator. So this is our 0-tick generator, as shown in the previous video. And then next what we have is our piston that pushes the mismatch elsewhere. And then we have a piston pulling it. And then it just starts falling down to the next module. But yeah, this is very non-compact, but it still works. So we can go ahead and sort red. It goes down to there. We could sort green or lime. That moves over to there. Falls there, and I could sort multiple other ones, and you'll see it still works. But let's go ahead and break down the timing. So starting from the string, once an entity falls through that string, the observer takes 2 game ticks to fire. It instantly opens this trapdoor. This observer takes another 2 game ticks to fire, so a total of 4 game ticks. And then it opens this. This is a total of 6 game ticks to fire. And then the repeater takes another 2 game ticks to fire per setting. So this is going to be 8 game ticks. And then this piston gets 0 ticked, so it instantly pushes the red concrete powder out. So in total, from this string, this is 8 game ticks. And then if we go ahead and count on the right side, this is 2 game ticks. A scaffolding takes 1 game tick to update, so this is 3 game ticks. This is 4 and 5 game ticks. This is 6, 7 game ticks. It powers this note block. This is 8 and 9 game ticks. So this piston 0 ticks in 9 game ticks, whereas this one fires in 8 game ticks, which is how the sorting works. So then There's some other components. These are pretty self-explanatory. After a certain amount of time, this piston is going to fire to push the mismatch elsewhere. And then this sticky piston pulls it out from here, and then it falls to the next module. So that is how that all works. It's really just a matter of counting game ticks to certain pistons. And then I tried another design. This design is 1 block shorter. So instead of 9 blocks per module, this one is 8 blocks per module. And I won't go through all the timings again here. But yeah, this is still pretty uncompact. It works, but yeah, it's pretty uncompact. So now let's get into some other designs. So this design is not made by me, but by my friend RedstoneYay on the CubeCrowd server. And it follows the same exact principles, except it is much more compact. So this one is only 1, 2, 3, 4, 5 blocks per layer, and then each module repeats. And again, this is 1 wide Tileable. I just have 2 rows right next to each other, and multiple modules stacked on top of each other. So we can go ahead and try and sort this. The red falls there. We can put in a blue. It falls to the next one. Then we can put something that doesn't match red or blue, such as sand. And then it falls all the way down to the bottom. And then of course we have our output lines, and then you could continue pushing your blocks out to wherever you want them to go. So this one does operate slightly differently than my designs over there, but it still works on the very same principles. So we have our detection of the falling block falling through here, and then it goes out to here, and then we have our 0 tick generator. So once this observer fires into this block, it instantly 0 ticks this piston, and the reason it 0 ticks this piston is because it powers this piston, but it also quasi-powers this piston, which instantly starts pushing the observer back, generating a 0 tick pulse. So we're powering this piston and also pushing away the source of that power back over to here. And then if we come over here, you can see that our 1 game tick delay is coming from logs and leaves. So if we push this log away, this leaf block gets updated 1 game tick later. And then this design that was made by RedstoneYay is an alternating design. So because we don't want the leaf blocks to interfere with one another, because that can cause unwanted issues because of the distances from the logs and stuff, this is an alternating design. So we have the logs and leaves in different spots, but still going out to the same output. So I guess you could call it 2 wide Tileable, but yeah, still very good design, but we can do even better. So before we get on to some of the final designs, I do want to show you this design, which was actually showed to me by a user by the name of Dampflock2000X in my Discord server. And as you can see, it's much different than the other designs, because instead of independently powering each slice, we're going to power each piston all together. We're just grouping all the pistons together. And so this means that all the control blocks will get pushed no matter if there's a block that they want to sort or not. So how does that not cause the control blocks to fall out? Well, I'll show you. So if I go ahead and place a red concrete powder here, for example, it's going to fire. And then as you can see, no control blocks fall out, and the red concrete powder falls down to there. I could do orange and place it up against this wall, and then it falls down to here. And the disadvantage of this design is that I wanted it to be 4 blocks between each module. So you can see 1, 2, 3, and 4. And then the next module starts here. But yeah, the disadvantage is that you continuously need new blocks behind it to push these blocks to the next sorting module. So not really great in that aspect. But let's go ahead and freeze the game. And I'm going to go ahead and place a row of blocks here. I won't place some blocks here. And then let's go ahead and advance the game. And we're going to 0 tick the left blocks, the control blocks. Then we 0 tick the other blocks. And then now there's going to be a 1 game tick difference for this block. And then how do we get these control blocks, which didn't have a block we're sorting in front of them, how do we get those ones back to the other side? Well, that is where these blocks come in. So somehow, these blocks that are falling right now, they don't get pushed over because these iron trap doors are preventing them from getting pushed over. So these continue falling. And then what happens is that we push these blocks back out. These pistons push the other control blocks back to the center. And then we pull everything back, and yeah, nothing falls out. and the ones that did match are going to fall down to here, and the ones that don't match fall over to here. So let's unfreeze the game. And yeah, there we go. So we would need a continuous stream. So let's go ahead and test this. Then you can see red continues to fall, and if we let it run for a little bit, you'll see that different blocks get sorted into the proper stacks. And there we go. Of course, with this one, we're sorting for red, orange, and yellow. And then we're not sorting for green, just anything that doesn't match red, orange, or yellow gets sorted to the last pile. So this design is technically the shortest of all the designs because it's only 4 blocks in height between each module. But yeah, I should mention that this original idea was by Dampflock 2000X, but I did add some components for automatic firing, such as these walls here, and I also designed it to push the blocks over, so I could design it differently. Technically, we don't need to be pushing it sideways so much. We could drop the mismatches directly into the next module, but that would just make it taller and yeah, not so good. And the other disadvantage, of course, is that this technically isn't one wide tileable, or I should say it's not infinitely tileable, because we need these control circuits over here. And so if you want to do this for a long row of blocks, you could possibly, stagger it back and forth. But overall, this kind of is just more complicated and harder to work with than our infinitely tileable versions. So let's get on to that. So this is pretty much the final design of the sorter, and this was made by my friend RedstoneYay on the CubeCrowd server, coming in at only 5 blocks tall per module. And then this is where your output line would be. So you could push this out here, and then of course you could stack multiple of these modules directly on top of each other, just slightly offset to sort the next ones. And yeah, I should mention that there's a creeper head here. You're probably wondering, like, why is there a creeper head here? Well, again, this has a unique property of being powered or not powered. So when it gets powered, it's able to update this observer. But this also isn't technically necessary. You could also use a trapdoor instead. But the creeper head kind of looks cooler. So, oh, and of course this is also silent when you power it, whereas a trapdoor is not. But already the whole machine already makes a lot of noise, so it really doesn't make much difference. So it's important to note that this device was made to have multiple of them stacked on top of each other. So if you weren't sorting for multiple, if you were sorting just for like one versus another, such as with Connect 4, you would only need one of these modules, but you need a different design. So I mean, you don't need a different design, but you can do it much smaller if you're only doing something like Connect 4. So you're sorting blue versus another color, or red versus another color, or whatever. So it's specifically made for the purpose of Connect 4. So while you could stack multiple of these on top of each other to sort different colors, it's not really optimized height-wise for sorting multiple colors directly on top of each other. Instead, what's happened is that I've specifically worked with RedstoneYay to compress it this way as much as possible to condense the overall size of my Connect 4 game. So you can really see all the components involved. This is one wide tileable, so each slice is exactly the same. We can go ahead and try and sort red or blue. So what would happen is that the concrete powder gets tossed up against these blocks and it falls through. So let's go ahead and sort red. It goes over to there because it's a mismatch. We can sort blue. It sorts, or sorry, it falls straight down. So let's go ahead and count the game ticks. So this observer, after the string gets updated, this observer takes 2 game ticks to fire, and then this piston fires, taking 2 game ticks. This observer fires, taking another 2 game ticks, so a total of 6 game ticks. And then this is 8 game ticks, this is 10 game ticks, this is 12 game ticks, and then this observer fires up into this for a total of 14 game ticks before this one gets 0 ticked. And then this piston is going to be 15 game ticks instead. So right here, this observer, 2 game ticks. The scaffolding takes 1 game tick, so that's 3 game ticks total. 4, 5 game ticks, 7 game ticks, 9 game ticks, 11 game ticks. This fires, so that's 13 game ticks, and then this observer fires up here, taking 15 game ticks. And something else I should mention is that we are being careful not to quasi-power this piston before it should. So if, for example, I went over here, and then we had a setup like this, this observer would power the piston when it shouldn't, because we want this observer to power it. So that's why we need a setup like this, so that only this observer is powering the piston. And then of course we also have droppers down here, and the reason that we have these is because these can also be quasi-powered, so they're getting quasi-powered through this piston at the same time as the piston, and then it goes out to here, and then it fires this piston, which will push the mismatch out of the way. So this is this whole setup. You can see everything involved here. And yeah. All right, so now back over here, I've gone ahead and taken this module right here and I've stacked it 2 times over. So this is still 1 wide Tileable, and I've stacked a few modules on top of each other, just 2. But let's go ahead and try this one out. And yeah, it is pretty loud. But we can sort multiple. And there we go. So you can see our red concrete powder got sorted to here, and we could push this out to wherever we want. We have our blue concrete powder here, and we have anything else down here. And so we could extend this to this giant machine here. And again, this is 1 wide Tileable, so very thin. I could stack this multiple times in that direction. But yeah, I've stacked it multiple times on top of each other. And so if we do 16 different concrete colors, that, if you do the math, it's 16 times 5. That takes up 80 blocks in height. So it is kind of tall. But theoretically, you could compress the output lines to condense into 1 point. But let's go ahead and fire this. Let's activate this. And you'll see, we have a whole bunch of concrete powder. I'm not going to wait for all of it, but you'll see that each one gets sorted to different locations. So let's go ahead and stop it there. And you'll see it keeps sorting some of them. And yeah, of course, this has the advantage over the original design that I posted by Fido and Zeoran, that you don't need a whole bunch of blocks behind them to sort new ones. So if you look here, we have our red concrete powder, we have orange, got sorted to this output line, we have yellow, we have lime, green, cyan, etc. just by stacking multiple on top of each other, and completely 1 wide Tileable. So there you go. I hope you learned something. I hope you enjoyed. Be sure to subscribe. I have some very, very fun stuff coming up, such as some mini games and very big stuff. You don't want to miss it. So be sure to subscribe, be on the lookout for that. And yeah, I will see you all in the next video. Have a good one.